yesterday, do you remember? We spent some time with the box problem. And then we talked about how we were going to handle the discounts and all that stuff that come up. Well, today we're going to do another variety of problems. And this number 5, which I took out of our textbook, this number 5 sometimes gives us trouble. So let's see if we can figure out. It isn't really a problem. I mean, we're not going to come up with an answer like 16. We're going to set it up. So it says, write a function. So write the specified quantity as a function of the variable. So in number 15, we have a right circular cylinder. So you all know what that looks like, right? I'm not a very good artist, but that's a cylinder. Like a paper towel. A cylinder. The height of the cylinder equals the diameter of the cylinder. Okay, so they are equal. Write the volume of the cylinder as a function of its radius. Now, that means we are going to write a formula for the volume. Does anybody know the formula for the volume of a cylinder? Just the general formula? Volume of a cylinder? Yeah, it's a triangle area, yeah. The volume of the cylinder is pi r squared h. And that equation, it gives me the volume. But it gives me the volume in terms of radius and height. My question says, write me an equation for the volume, but it can only have r's in it. Write it as a function of the radius. That means I gotta get rid of the h. Okay, can I do that? H is diameter, but what's diameter? Double radius. So I'm going to take the h out and replace it with double radius. And now what will my equation look like? V equals pi times what? R squared times 2r, which simplifies to 2 pi r cubed. And now my volume equation, instead of being what the original was, this is what you see when you open up your geometry book. But this has 2 variables, radius and height. Your question was, make it 1 variable. So we were told that h was the diameter. Diameter is 2 times the radius. So we took out the h, plugged in 2r, simplified, and there you go. That's what we were doing. That's the goal. All right, so let's see about number 16. Now we have a right triangle. And you know from geometry that these are called the legs, and that's called the hypotenuse. One leg of the right triangle is twice as long as the other. So if this one's x, this one would be 2x. Right? Now I'm supposed to write a equation, a formula, for the length of the hypotenuse, called C, in terms of, or as a function of, in terms of the length of the shorter side. Now, just stop for forget all that stuff. How do you find the hypotenuse of a right triangle? It's a squared plus b squared equals c squared, right? And what are a and b? A and b are the legs. Okay, so what are my legs? My legs are x, so x squared plus 2x squared. Those add together to make what? If you say 3x squared, I'm going to come back and hit you. What do these add up to here? That's 4, so it's 5x squared. Now, I need a function, so I need like c, not c squared. So what do? You go by square root, and be careful when you square root. Oh no, not this time. Can somebody, good though, good to be thinking about that, but can somebody tell me why I don't want plus or minus this time?
Oh, because you can't minus.
Can't have a negative hypotenuse, right? So, yes, I want you to think about plus and minus all the time, but not this time, because that can't be negative. So what does it equal though? X root 5. There's your formula. Now, I used C. Could I have used Y? Or, better yet, could I have used function notations? Yeah, that would be perfect. Alright. The base of an isosceles triangle. Okay, what does that mean? What's isosceles?
All equal.
They're not all equal. In an isosceles, these two are equal. And this one is called the base, right? So the base of the triangle is half as long as the two equal sides. So if this is x, would these be 2x? Now I'm cheating a little bit because I'm reading ahead. I am supposed to write my equation as a function of the length of the base. So the length of the base has to be my x. Because I heard some of you say x, 1/2 x. And that would be okay, except your x is the side, and the problem says x has to be the base. But write the area of the triangle as a function of the length of the base. Write the area of the triangle. Okay. What's the formula in general for the area of the triangle? Do you guess you knew this?
Oh, 1/2 base.
Mm-hmm. 1/2 base times height. Now that's a great formula, but it's in terms of base and height, and it's supposed to be in terms of x. So I'm in luck. What's my base? Okay, so I'm gonna make that an x. That's good.
Height is.
Now, no. This is the height. Would everybody agree with that? This is where things you have to be thinking. Shake those french fries out of your blood and let's. I walk down there and see what people eat and I just feel my blood getting thick. All the cholesterol.
What's your favorite meal?
Well, I'll be honest with you. My two favorite things to eat are cherry tomatoes and Hershey Kisses. Isn't that terrible?
Cherry
Tomatoes
tomato.
are okay, but I eat a lot of chocolates. Okay. All right. So, help me out here. How am I gonna find my height? Anybody have a thought? What kind of triangle is this right here?
Right triangle.
Okay. And what do we know about erased it, but what do we know about every right triangle? A squared plus B squared equals
C
C
squared.
squared. So, what do I know about the length of this? Now be careful, how long is this? 1/2 x. And that is h, and that is 2x. So 1/2 x squared plus h squared equals 2x squared. These problems are getting you ready for calculus. You're gonna have to do this in calculus 1, I promise. And the whole deal is, you take something that has two variables in it, and you get rid of one of the variables. And that always involves, I shouldn't say always, but usually involves doing some other equation so that you can substitute it in. So here we go. What's 1/2 x squared? What's 1/2 squared? 1/4 x squared plus h squared equals 4x squared. What is 4 minus a fourth? 3 3/4, which is kind of awkward. 15/4. So if I put my x squareds together, h squared equals 3 3/4 or 15/4. Now I need h, because that's what I'm going to substitute in right here, is h. So I'll square root again. What will h be? What will my h be? Square root of 15 over 2 x. I know it's hard, especially right after lunch. Don't lose sight of what you're doing, what you're trying to do. You're trying to write this formula with only x's. So b was x, so that was easy. H, we had to do the Pythagorean theorem to figure out what h is. Then I could plug that in here. So now my final answer,
Where'd you plug this?
right here. So my final answer is going to be all this times each other. So root 15 over 4 x squared. X times x, root 15 over 4. It ain't gonna go away, people. Please don't ignore it. Okay, here we go. A square is inscribed in a circle. So that means it's tucked right inside just like this. Does that make sense to you? Right? The area of the square, what's the area of the square, as a function of the radius. Who can tell me what that means?
Find both areas and subtract.
Yeah.
What's the formula for the area of a square? And since it's a square, length and width are the same, so we normally just say s squared, side squared. But that is length times width, they're just the same. Now, this is a formula for the area of a square in terms of its side. Right? Now, what is the question one? Write the formula for the area of a square, only instead of having the sides, we want the radius. That's what it says in the problem. So you have to find a relationship. Here are a couple different ways. I'll just go here. And that would be another radius, right?
Would they be the same? Yeah.
not only are they the same, because the radii of a circle are the same, but not only are they the same, but they're perpendicular. You might not remember that from geometry, but they are perpendicular. The diagonals of the rhombus, the diagonals of the square are perpendicular. So do you see an equation in there? That's a right triangle. Do you see a little equation in there? What equation do you see? R squared plus R squared equals S squared?
That little.
Yep, this is a right triangle right here.
Jeez.
So 2R squared equals S squared. What's this? This was the area of my square. What do I know S squared equals?
2R squared.
Two and a half that.
So can I just write area is
2R squared.
squared?
Yeah.
These are exactly the same equation. They give you exactly the same information. This one is in terms of the side, and this one is in terms of the radius. But they're the same. Okay, we only have 2 more, so you guys start getting the hang of this, folks. Here we go. Now we have a sphere contained in a cube. So I'm not going to draw this 3-dimensionally because I can't. I'm terrible. But I am going to go ahead and try from the side view. So here's my cube, and here's my sphere. So it's like you put a little ball inside of a box, and it just fits, okay? Tangent to all 6 faces, so we're touching. It just fits perfectly in the box. Find the surface area of the cube. Okay, stop right there. Think of a cube. Think of a cube, okay?
Cube back there.
Are all the faces of a cube the same size?
Yes.
And they're all what shape? Squares. Okay? And how do we find the area of a square?
Take half of it.
S squared, right? The area of a square is S squared. Now, how many faces does the cube have?
6.
So the surface area of a cube would be 6S squared. Correct? And this is S. That is a perfectly magnificent formula, but it's giving me the area in terms of a side. I want the area in terms of the radius. This, this would be a radius. Isn't this also a radius?
Yeah.
So a side is the same as 2 R's?
Yeah,
But
Two
what
R's
R?
squared.
What radius? So I'm gonna come down here, take out the S and put in 2R. Now I still need to square it. Formula says square it. Okay, something is happening in my family. This is my.
How good.
No, it's my siblings. They have nothing to do with it. Okay. You know, when you have like an office job, you can do that kind of stuff. They don't want to know what it's like, you know, when you're.
Teacher.
Yeah. All right. 2R squared is 4R squared. So the answer to the problem is 24R squared.
Simple enough.
Last one.
That's correct.
No, these are all the same. You just have to really think about them. All right, here we go. An isosceles triangle has its base along the x-axis with one base at the origin, or one vertex at the origin. Its in the first quadrant.
All positive.
And its vertex on the graph of 6 minus x squared. Okay, what shape is 6 minus x squared? That's the same as negative x squared plus 6. A parabola opening down that's been lifted up
6
6.
places.
So this is 6 up here. Here is, I'm gonna have to draw it the other way first. So I'm gonna draw my parabola first because I'm not. So there's my parabola. Now, the triangle. Triangle looks like that. That's an isosceles triangle. The vertex is on the parabola. First quadrant, right? The area of the triangle. All right, so the area of the triangle we already said is 1/2 base times height, right? We already did that. Now, the question says, write the area of the triangle as a function of the length of its base. So if I call the base x, then I still need to find the height. Right? Now, the base is x. That is a done deal. However, this much of it is what? What would this much of it?
Radius. 2r.
Half of x?
Yeah.
Half of x? Half the base? So whatever this point is up here, its x coordinate would be 1/2 x. Does that make sense to you? That's 1/2 x. So I'm going over that far and then I'm going up h. I don't know yet. I'm going to figure it out. But remember, all of the y's on this thing come from that equation. So if x is 1/2 x, then my y for this point right here, my y is going to be 6 minus 1/2 x squared. Now, I know it's all letters and that's what's making it confusing. But if I told you this point right here has an x of 4, how would you find the y? Plug it in. So what am I doing? I'm plugging in my x. So I plug it in, and that right there, you guys, is your y coordinate. And your y coordinate is the height. Don't tune me out. You gotta pay attention, get a 0 in, and get whatever you can. I know it's hard. Right? You're all heading to calculus at some point. You're gonna need to be able to do this. Well, I mean, like right away, in like the first month of school. So what have I got? 3x. That's what I get when I multiply all this. 3x minus 1/8 x cubed.
What about that? Never mind.
I know, that's hard.
Oh, 1/2.
All right, let's try a couple of easy ones now. We've got you tried. Let's try a couple of easy ones. One's numbered or letter G. Letter G. happened to you? Ruth is looking for a job. She's been given two possible jobs. One offers a base salary of $25,000 plus 5%. So you've heard of selling on commission. This is what's happening. She gets 5% of whatever she sells. The other one gives her a $20,000 base salary, but a 7% commission. So does it make sense to you that initially, this one sounds better because she's making $5,000 more guaranteed? But if she's a good saleswoman, do you see that eventually this one might be the best deal? Because if she sells a whole bunch of stuff, 7% is more than 5%. Alright, so what's the question? What would Ruth's gross sales need to be to make the second one more attractive than the first? Alright, now you don't need a formula, you kind of got it here, but you do need to write an equation. So what do you think that equation would be? We want the second job offer, we want this one to be bigger than this one, right? So what would that look like? 20,000 plus
0.07x.
0.07x.
Joe.
And we want that to be greater than
25,000 plus 0.05.
There we go.
There you go. Now we're just going to solve it like a regular equation. No
yeah.
trickiness deal. So 0.02x, be careful. 0.07 minus 0.05 will not be 2, it's 0.02. Greater than 5,000. So I should be able to do that in my head. 100,000. 5,000 divided by 0.02. No, I'm not even close. It's 250,000. So what would her sales need to be for the second one to be the best deal?
Over 250.
Something over $250,000.
Take the first deal.
What?
Take the first deal. It's a lot. That's
More of a risk taker.
All right, mixing solutions. For some reason, these problems historically have been an issue. So I'd like you to think about it like this. Read the problem. I got two solutions, I'm mixing them together. I got a strong one and a weak one, I'm mixing them together to get a medium one. Okay? This will always work. If you take the amount of the first solution times its percentage and add the amount of the second one, why are we talking back here? Times its percentage, we will end up with the amount times the percentage of the final solution. Alright? So amount times percent plus amount times percent equals amount times percent. That will always work in these problems. Always. Now, are there other ways you can do it? Yeah, but this will always work. So, what have I got? How much 10% solution must be added to another amount of 45% solution to end up with 100 gallons of 0.25 solution. Now, don't put an X here. Because if you put an X here, what would that mean? The two amounts were the same. And do we know that? No, so don't put an X there. What do you want to put there? Okay, I can put a Y there, but now I got big problems, because now I have one equation, but two variables. You can't solve that, people. You can't solve that equation. However, do I know anything about X and Y? Don't they have to add up
X
to
plus Y equals 100.
100? So now I know that Y, right here where I had Y before, I'm gonna put in, what's Y? 100 minus X? I can put that right here. And now I have an equation that I can solve. Remember, if you're gonna end up with 100 gallons, and you dump in X, then the other part you dump in has to be what's left, 100 minus X. All right, let's use a calculator and figure this out. Actually, I don't even need a calculator. Yeah, I need one.
Yeah, please.
57.14 gallons, I'll say 143 gallons. And what is that? That was X. And what was X? The 10%? So we need roughly 57 gallons of the 10%, which means I need 43 gallons, more or less, of the other kind. All right, have a great day. I'll see you tomorrow. Yeah, it'll be somehow. Unknown at this point.